and welcome to our presentation. Today, our team will be presenting our Engineering 3100 project to you. Our team name is Inclusis, and let me introduce our team members. First of all, we have Amir, who is the project manager, Kian, software engineer, Najam, systems engineer, Shura, hardware engineer, and myself, Yannick, network communications engineer. Let me start off by showing you this picture. Is it familiar to any one of you? It surely is for most of us who have to commute to university by bus, and usually this one happens right after. Yes, you end up missing your bus. So as you have probably guessed it, today our team will be discussing about bus occupancy. So not being able to know how full your next bus is going to be greatly affects many public transit users. As it can be seen on this pie chart, bus is the most used public transit, occupying 63.5% of that space. And missing your bus and having to wait for the next one present a number of problems, which can be grouped into three categories, namely socioeconomic problems, environmental problems, and personal problems. Therefore, to solve this problem, our team has decided that the best solution would be to provide real-time information to transit agencies about bus occupancies, which we will explain throughout today's presentation.
Next, I'll be discussing the scope of the project. Commuters today are facing mainly two problems: late arrivals of buses and overcapacity. The timeliness issues are mainly due to external circumstances such as traffic and weather and is not related to the scope of the project, while overcapacity is due to inadequate buses being available during peak hours and routes. The service unavailability is causing economic problems to bus transit agencies and environmental problems. Ride-sharing apps and taxi services are becoming more and more popular, and so is the use of personal vehicles for commuting. This is causing more emissions every day. There are two approaches to solving the problem. One is purchasing more resources. Secondly is intelligent resource management. Purchasing more resources means buying more buses and allocating more manpower. This is a quick and easy fix, but at the same time is costly and doesn't scale well with time. Redistributing resources involves tracking the use of buses and allocating resources accordingly. This is a better utilization of resource. It saves time and costs while keeping passengers informed, but it requires expertise and accuracy is sometimes hard to achieve. To sum up, the project would involve calculating occupancy with accuracy and transmitting it in real time. Development would start off with Guelph Transit Agency and will eventually be extended for public usage.
I'd like to talk to you now about some of our constraints and criteria. Upon scoping the problem, a list of constraints and criteria were developed to help define our solution. Our system had to be able to collect information on bus occupancy, route, location, and time. This information would have to be transmitted within 1 second and be correct at least 98% of the time to be effective for active users. The system would also have to be totally non-invasive and anonymous. We also determined that the system should be as resilient, cheap, and accessible as possible while maximizing ease of installation.
So moving on with required information and tools. In order to design a solution to the problem, it was important to collect relevant information from the client, undergo literature review, as well as to understand the skills required, which was collected through online research and through brainstorming with the team. Afterwards, a Gantt chart was developed, which served as the most fundamental tool for keeping track of the project, laying out the important tasks at hand, as well as distributing the tasks among team members based on their expertise required to develop a solution.
The rank order criteria is used to gain weight factor of each criteria. This method works by assigning a value of 0 and 1. A value of 0 illustrates that the criterion in the column has more importance than the row, whereas a value of 1 represents the criterion in the row has more significance than the column. As an inclusive team, we are aiming for the solution to be as physically resilient with the maximum weightage. For the transit, we wanted the solution to be as low cost to have maximum weightage. And lastly, for the government, it was calculated the solution should be as accessible with the highest weightage of 50%. The sensitivity analysis is used to predict outcome of project. From the three weighing schemes, our team, transit and government, the camera and the computer vision is the most desirable solution as it has the highest total of 800 and is chosen as the final design.
Next, I'll be discussing the design overview. The scenario involves people boarding on and off the buses, and we're aiming to count them using 4 easy steps. Firstly, acquire their image, then detect their motion, then calculate the occupancy, lastly transmit the data. This will be done using a module mounted at each entrance that will be responsible for performing head counts. The module consists of a high-definition camera for video capture, Arduino Portenta for storage, detection, occupancy count, and transmission. SIM card will be used for cellular data transmission. The block diagram shows how these components will be connected. Software implementation starts off by data collection phase, which involves recording the video at optimized resolution and frame rate and storing that on an SD card with low latency. The data processing phase involves pre-processing the image to be fed into a machine learning model that has been pre-trained to detect people from top view images anonymously, and then calculations are performed by combining the detected images by taking into account the direction and finalizing a count. Data transmission phase can be described using three S's: standardized, secure, and swift. MQTT protocol, which is an IIT standard protocol, has been used. AES encryption for enhanced security has been used during data transmission. The transmission latency and processing latency are real time and thus is very low.
The device is intended to be installed above both entrances, allowing the device to count users that enter and exit the bus. The camera can be installed anywhere on the vertical axis above the door, either at the door frame or the roof. The diagram shows the lowest possible installation point and proves that the device can cover the full width of the bus aisle. By installing the device above the door, the device does not obstruct riders and it should not impede their riding experience. So now that you understand how our solution works, I'd like to talk to you about how you can actually use the information we're collecting for you. As mentioned in the scope, our solution is only intended to collect the aforementioned data and send it to the transit agency. Once this data is stored in the backend server, it will be up to the transit agency to determine how to use the information. We recommend using the data primarily to reschedule and optimize bus routes around ridership based on time and location. This information can be an incredibly powerful tool in improving the service that is currently provided. The information can also be shipped to users through a front end on mobile devices or through a web browser, either through existing or newly developed services. By forwarding select information to users in real time, the users will have more tools at their disposal to plan their trips, which can lead to happier customers.
Now let's move on to the social and environmental aspect. On the social aspect, one of the main problems which bus users are currently facing is severe inconvenience whenever the next bus comes overcrowded and they cannot get in, especially during rush hours and winter. Our design has the potential to rule out completely this problem when real-time information will be communicated to transit agencies, which in turn can adjust their operations accordingly and provide a better service. Another point is that it can help businesses and individuals better rethink their decisions. One other aspect is the environmental aspect of the solution. What our team has designed has the potential to save up to 450 million gallons of fuels based on a study done by the American Public Transportation, which can be greatly beneficial to the environment.
Moving on to life cycle costing. So based on the life cycle assessment of the product from cradle to grave, it is clear to see that the bus occupancy tracking system will significantly produce lower level of greenhouse gas emissions than the recent Apple Watch and the Bose Bluetooth speaker over its useful life. Both these products have recently outperformed the Energy Star standards of eco-friendly products, indicating that our device has much lower greenhouse gas emission than some of the eco-friendly products on market, and with an overall efficiency of 85% and power consumption of only 23 milliwatt, the device clearly maximizes resource utilization, which makes the product greatly suitable for the greater future. Next, I would like to talk about the economic costing of our product. For the 2018 fiscal year, the World Transit Agency reported a net loss of about 9.8 million, with an estimate of 3.6% of the revenue that was lost due to overcapacity, and therefore missing out on a lot of potential passengers daily. Now, with an investment of about 1.6 million, including periodic maintenance costs, the agency will have the device at their disposal, which can help to completely recover those missed passengers and increase their annual revenue through proper utilization, as previously mentioned. Based on the annual revenue growth, the maximum estimate of the payback period comes to only 2.75 years based on benefits of regaining those missed passengers alone, but in reality it can also potentially increase the number of annual memberships due to improved services, which will significantly lower the payback period, making this a fruitful investment.
In the past 10 minutes, we've explained to you a viable solution to the lack of information in the public transit sector. Our solution promises to bring accurate, real-time data to your transit agency through a user-friendly, environmentally conscious, and affordable implementation. We at Inclusys truly believe that these devices are the next step in improving your ridership experience. We hope that through this presentation today, we have inspired in you the same confidence that we have in our solution. For further information or access to formal documentation, please don't hesitate to contact any one of us and we'll do our best to assist you. Thank you for watching.